We're going to go over a related rates problem that involves the filling of a conical tank. We are told that water is being pumped into an inverted conical tank. I have that picture down here in the diagram so you can see what it looks like. And the water is being pumped in at a rate of 2 meters cubed per minute. We're told that the tank has a height of 6 meters and a base radius of 4 meters. We want to find out how fast is the water level rising when the water is 2 meters deep. Let's now write down what we're given in this problem. We are told that the water is being pumped into the tank at a rate of 2 meters cubed per minute. So that means the rate of change of the volume is equal to 2 meters cubed per minute. And that's positive because water is being pumped in. We're told that the tank has a height of 6 meters. So we'll say h is 6 meters. And then a base radius of 4 meters. So r is 4 meters. And let's put that the radius is 4 meters. And then the height of the tank is 6 meters. Now let's look at what we have to find. We want to find how fast is the water level rising. So when the water is rising, the height of the water is changing. So we want to find dh dt when we're told the water is 2 meters deep. So that means the height is 2 meters. Now we need to think about an equation. We need to find an equation that is going to relate the volume of our conical tank to our height. That formula is the volume is 1/3 pi r²h. Let's now look at this equation that we just wrote down. Our equation has a volume in it. It has a radius and it has a height. We want to find dh dt. We are given dv dt, but we are not given any information about dr dt. So what we have to do is we have to put r in terms of h. And the only way that we know how to do that is to use similar triangles. So I am going to take just the cross section here of our cone. We were given that the radius is 4 and the height is 6. Now let's think about some water being pumped in. Let's say that this is how much water we have. So we can call this the radius and then this part here the height. We have then two similar triangles. Here's the first one, where we have radius 4, height 6. And then our second one, we have a radius and a height. And they share common angles, so we can use what's called similar triangles. Similar triangles tell us that the ratio of the size of the conical tank, 4/6, is equal to the ratio of the radius to the height. We can then solve for r, so we find that r is equal to 4/6 times h, which is 2/3 times h. Let me go ahead and highlight that because that's what we're going to plug into our formula. Our formula is v is equal to 1/3 pi r²h. Now we're going to substitute in that r is 2/3 h. So we have 1/3 pi, 2/3 h, that gets squared, times h. Our volume then is 2 squared, which is 4, and then we have 3 times 3 times 3, which is 27, so we have a 4/27 pi h cubed. Now we can take the derivative. we have dv dt on the left, and on the right, we have 4/27 pi times 3h squared times dh dt. Let's go ahead and cancel that 3 out. This then is 4/9 pi h squared dh dt. Now let's think about what we want to find. Let's go back up here. We want to find dh dt. So I am going to go ahead and highlight dh dt. That's what we want to solve for. So we can say that dh dt is going to be 9 times dv dt, all divided by 4 pi h squared. We want to find the rate of change of the height when our height is 2 meters. So this is 9, and then dv dt, let's go back up. It is 2 meters cubed per minute. 2 meters cubed per minute. And we divide that by 4 times pi times 2 meters squared. It's really important to put units in at this point so that you know what the units for your final answer are going to be. 9 times 2 is 18. And then in our denominator, we have 2 squared, which is 4, times 4, which is 16. So we have a 16 pi. And then our units are going to be meters per minute. We can divide both the numerator and the denominator by 2. So this is 9/8 pi meters per minute. This tells us that our water level is rising at a rate of 9/8 pi meters per minute.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.